Hello, my name is Corey Stevenson and I'm an engineering student. I would like to share with you this template that I've adopted for solving various engineering, physics, and mathematics problems. It can be used for, um, generally speaking, any STEM related course science, technology, engineering, and math. Um, The point of this video is not for me to convey the actual solution to the problem in this example, but it's just to communicate the process that I used to solve problems like these. So, with no further ado, I'll get started. So, up here I have the course number, and below that I have the semester in which I took the course. Over here I have the assignment number and the due date for that assignment and the time that it was actually due. Over here I have my name and the current page out of the total number of pages underneath that. So, and before I forget, um, this is a good thing to do. Like, if you've got multiple pages in an assignment, um, all of the following pages following this first initial um, page, you want to be sure to write out your name and the current page out of the total number of pages in the same spot on the page in the case that any pages get misplaced or ripped or torn out or separated from any of the other pages. You have a way to um, keep track of the order of the pages, and somebody else picks them up, you also have your name. So it's just a good practice for if the pages get separated from each other somehow. So underneath these three sections, I have written down the assignment details, and directly underneath that is where I actually get into the meat of this problem. So right here I boxed in the problem number that was given in the textbook. I've written down over here the assumptions that were given in the problem. To be more specific, any special considerations or special conditions that were given in the problem, you'd want to put those right here. So, in the case that you're asked to neglect the forces of friction or the forces of air resistance, um, which is uh, quite common in high school physics, from my experience anyway. Um, so, anything of that nature, you want to put under assumptions right here. And then after that, I've written out what I'm asked to find in the form of a question. So you write that out, and underneath that out, you write out whatever you're given in the problem in the way of mathematical constants or physical constants or weights or magnitudes of any kind, um, anything of that nature. So that goes there. And equations and formulas, any relevant equations and or formulas, they go right here. And obviously I was experimenting with Roman numerals. Um, what I was trying to do here is it was also recommended to me at some point that I try to uh, differentiate between equations and formulas. Um, that's not to be confused with differential calculus. If you're in any calculus classes, just so you can tell the difference between equations and let's say if you've got a formula that's in an equation and it's supposed to be substituted in for the same variable in another equation and or formula, you have a way to do that. Uh, if you give each one of the equations and formulas a specific indicator or identifier like that. So um, you may want to try lowercase letters, uppercase letters. You can do whatever you want, really, but um, just get a little creative with it and see what you come up with yourself. So I just wanted to mention that. Um, After the equations, you write out the solution, and as I've indicated here, you just want some way to draw attention to your solution in the problem. So it could be a box, it could be a circle, it can be whatever you want. Um, After that, it'd be a good idea to write down whatever conclusions you actually draw from the solution in your problem. So, anything that you think is relevant for the problem at hand, this goes there. And you can see for um, this multi part problem, I've used the same process for all three parts. So, also with the formulas, I'd like to say that it is sometimes or also been suggested to me that you try any basic algebra, or if you're asked to isolate for a certain variable, um, do the basic algebra and isolate for the variable first before you plug in any actual numbers. And depending on how difficult the problem is, isolating for variables first before plugging in any numbers could be quite helpful to you. So I just wanted to mention that as well. Um, I've also sketched out a simple free body diagram. I would recommend that you try to um, keep the free body diagrams as simple as possible, but um, I just think free body diagrams are beneficial in engineering and physics problems in general. You see them all over the place all the time. So it just helps to make the problems at hand a little less abstract, and so that you don't have to really see it in your head. You can sketch it out on paper and make sure you can um, make sense of the actual concept for the problem. So I just wanted to mention that lastly. But again, this is my template for how I solve a bunch of math, engineering, and physics problems. And it's particularly useful for word problems. Um, but yeah, um, that's it. And hopefully, this helps any students that are kind of struggling with math, or this would just help to um, make your handwriting a little neater and a little more consistent. So, and I think your instructors will really appreciate something that looks like this or similar to this or um, just it would just help, I think. So, um, thank you for your time and have a nice day.